Welcome back to my YouTube channel. Now, today we'll be doing Newton's laws and application of Newton's laws. But before we begin, we need to look at some of the definitions that are very important for you guys to know. Okay, and definition number one is going to be your normal force. And your normal force is defined as the force. Okay, I don't know why this is not working. Okay, sorry about that. It is known, okay, let me write the definition down here. It is known as the force or a component of a force, okay, which a surface exerts on an object with which it is in contact with, right? And this force acts perpendicular. I'll just use, yeah, it'll act perpendicular to the surface. And what they mean by that is that consider this slope, this flat plane. Okay, you have an object over here, and this object exerts gravitational force, okay, on this surface over here, on this surface here. And so the surface is supposed to exert a force with equal magnitude but in the opposite direction, okay, so that the forces balance out. So this force, the one above, this force and this force are of the same magnitude but in a different direction, okay. You can also have an inclined plane where your object is sitting like this in an angle. Let's say the angle is 30 degrees, right? And when you have something like this, now the normal force is no longer going to be equal to the it is no longer going to be equal to the gravitational force. And this is why. So the gravitational force, let me use a different color, sorry. Okay, I'll just use brown. So the gravitational force acts downwards, right? And the normal force is supposed to act perpendicular to the surface at 90 degrees with the surface, okay. And this force over here is exerted on the object, okay. Now this force is going to be equal to a force that this object exerts on the surface, and that force is supposed to be like this in the opposite direction, right? And yeah, it's also perpendicular to the surface. And you can find this force by constructing a right angled triangle, okay. And wait, is this the actual, yeah, okay. By constructing a right angled triangle where now you have FG parallel and FG perpendicular, and you'll get to understand what this is as we do more examples, okay. Now moving on to the next definition, sorry. Now the next definition is frictional force, okay. Frictional force. Now frictional force is defined as the force that opposes the motion of an object and it acts parallel to the surface. Okay, I'm not going to write out the definition, it is on your exam guideline and I'm reading it exactly as it is. Okay, so it is defined as the force that opposes the motion of an object. Okay, and that it is parallel to the surface. So consider this object over here. We have a surface, right? And this force is supposed to act parallel to the surface, either in this direction or in that direction. Okay. um, Another definition is static frictional force. So with friction we have two different types of frictional forces, right? We have the static frictional force and we have the kinetic um, the kinetic yo the kinetic frictional force, right? Now the static frictional force is defined as the force that opposes the tendency, okay, of motion of a stationary object relative to the surface. So let us say you have an object and a surface, right? And this object, okay, it is sitting on this surface, right? And someone is pushing this object with a force of 5 newtons, but this force is not enough to push this object to keep it moving. So the force that this object also exerts on the person or on whatever is exerting a force right here is going to be 5 newtons. Okay, so this force opposes the tendency of motion. Now it doesn't oppose the motion because the object is not moving, but it opposes the tendency of motion of that object, so it's keeping it from moving, right? And then we have kinetic frictional force, where when you have a surface like this and someone exerts a force of, let's say, 10 newtons, okay, and um, the surface and this object create a frictional force of 3 newtons, obviously in the opposite direction, right? The object will start to move. The object will start to move, okay, but there is still friction. It doesn't mean there's no friction, there's still friction, but now it's kinetic friction because the object is moving. Okay, um and there's two formulas that are very important for you to know. Number one is the formula for static frictional force, right? Or not just the static frictional force, but the maximum static frictional force. So it's defined as Fx max is equal to I don't know what the symbol is called, but this symbol over here, and multiplied by the normal force. So this symbol over here represents the coefficient of static friction, right? And for the kinetic frictional force we have Fk. Okay, Fk is equal to the coefficient of kinetic friction multiplied by the normal force. Okay, now the difference between this formula and this formula is that this one only works when you have the maximum static frictional force. Okay, it doesn't work with any other type of frictional force. I mean, with any other type of static friction, you must always have the maximum static frictional force, while this one works on any type of kinetic frictional force, right? Okay, now when you continue reading the exam guidelines, they say, note that if a force F is applied to a body parallel to the surface does not cause the object to move, then F is equal to the magnitude of the static frictional force. Like I said above there, that if, let's say, a force of 10 newtons, oh my god, okay, the pen is glitching, of 10 newtons is applied to this object, but now this object doesn't move. The magnitude of the static frictional force is going to be equal to this force over here. So these forces actually cancel each other out. And as we do more and more examples, you get to understand why. Okay, but it is in the opposite direction, right? And then they say that the static frictional force is a maximum just before the object starts to move across the surface. Okay, so let's say someone applies a force of 15 newtons, but this object is just about to move. If this person applies a force of 15,01 newtons or 15,1 newtons or 20 newtons, as long as it is above this, and it causes the object to start to move, it means that 15 newtons is equal to the magnitude of the maximum static frictional force. So this is Fs max. Okay, so if they apply any force that is higher than this, the object will start to move. Now, if the applied force exceeds Fs max, a resultant force accelerates the object. Like I said, if we apply this force, although it is higher than 15 newtons with just 0.1 newtons, since it is higher, it will start to cause an acceleration on the object. It will accelerate the object. It will move the object. Okay, yeah. And you're supposed to know how to solve problems using this formula over here. These two formulas, actually, you're supposed to know how to calculate the coefficient of kinetic friction and the coefficient of the static friction, as well as normal force, as well as Fs max, given the two other variables. Or even if you're not given, you must know how to calculate them, yeah. And then you must know how to draw force diagrams. So a force diagram, okay, is something that looks like this. Okay, let me erase this dot. Okay, now so this is your force diagram, right? Where this thing over here is your object, right? We have the normal force, we have the gravitational force, we have tension. This is a T, a very beautiful T, by the way, and we have Fk. So Fk is the kinetic frictional force. This is your tension, this is your normal force, this is your force of gravity. But now notice that gravity always acts on the object from the center of gravity. On a normal object, it is right on the center of the object. In high school, you're only going to calculate, or you're going to draw your force diagram starting in the middle, okay, in the center of the object, for you to represent Fg. And then for normal force, your normal force is exerted by the surface on the object, right? And it is exerted right here, so that's why it starts at the bottom and it goes up. And then we have tension. Tension can either start from here and go out, or it can start from here and go outwards. It depends on your scenario, right? And we have Fk. Fk, you can draw it from here, you can draw it, doesn't matter, it doesn't really matter, but this is your force diagram. And then we have something called a free body diagram. Let me increase the size here. A free body diagram where your object is represented by a big dot, and then you can have your FG, you have your normal force, you can have your tension, you can have your FK, right, etc, etc. The only difference is that this one is represented by a dot, and this one is also is represented by a box. Okay, doesn't matter if your object is a sphere, you don't draw a circle, you just use a box. Okay, resolve two-dimensional force. Okay, you're also required to know how to resolve a vector into its components, meaning the x component and the y component. Okay, you must know how to do this, and you must also know how to take components or different forces and calculate the resultant force given their magnitudes, right? Also, in an inclined plane where you're given the gravitational force and then you're given an angle 30 degrees, this 30, the font size is way too big. Okay, you are required to know how to resolve this force into its horizontal and its vertical component. Okay, not horizontal and vertical, because in this scenario it'll be irrelevant, but your perpendicular and your parallel component, where this is your perpendicular, is your FG perpendicular, and this is your FG parallel, right? And this over here, okay, so this is 90 degrees. Yeah, in other videos we'll get to see how you calculate all this. Okay, so yeah, I think we're done for now. In the second video we're going to do an introduction to Newton's first law, second law, and third law, as well as the law of universal gravitation, and then we'll do past question papers. Thank you.